Find the points xy at which the polar curve r equals 6 cos theta has a vertical and horizontal tangent line, and choose theta values between negative pi over 6 and positive pi over 3. When we are looking for places where a curve has vertical and horizontal tangent lines, that's equivalent to asking where is the slope of the curve undefined and where is it equal to 0. Specifically, in order to even begin this problem, we want to find the slope of the curve at any point. That is, we want to find dy dx. And we might recall that dy dx is in fact the same as looking at dy d theta divided by dx d theta. And that's equivalent to dr d theta sine theta plus r cos theta divided by dr d theta cos theta minus r sine theta. And if you've forgotten how to prove that or where it comes from, just feel free to email me and I'll be happy to show you. But knowing that we have our formula for dy dx, this is what's going to help us to get our vertical and horizontal tangent line. Let's start by actually calculating dy dx for our polar curve r equals 6 cos theta. So let me start by writing r equals 6 cos theta. And I know I'm going to need dr d theta, so let's go ahead and calculate dr d theta. The derivative of 6 cos theta is just minus 6 sine theta. Now I think we're good to go. So for our polar curve r equals 6 cos theta, we can see very quickly then that by doing a little bit of substitutions, we have that dy dx is in fact dr d theta, which is negative 6 sine theta, times sine theta, plus r, which is 6 cos theta, cos theta. And that's all divided by dr d theta, which is minus 6 sine theta cos theta, plus r, which is 6 cos theta sine theta. And looking back over my work, I see I made a slight mistake here in the denominator. The bottom should be dr d theta, which I do have as minus 6 sine theta, times cos theta, but there's a negative sign here that should be in front of r, and r is just 6 cos theta times sine theta. So that bottom should have a negative right there. So I want to make sure I correct that before going any farther. So now I want to clean up dy dx. You don't have to, but I just like to look at it. And that's going to look at it when it's a little more simplified. So I'm going to factor out a negative 6 in the numerator. That's going to leave me with a sine squared minus cosine squared in the numerator. And in the denominator, when I factor out a negative 6, that's going to leave me with sine theta cos theta plus sine theta cos theta. Now, it's apparent that I can just take and cross out that negative 6 from numerator and denominator, leaving me with sine squared minus cosine squared. And if I like, I can remember my double angle identity. I don't have to, but it might help us clean this up a little bit more. Sine squared minus cosine squared is actually negative the cosine of 2 theta. Because cos 2 theta is cosine squared minus sine squared, so that's negative the cosine of 2 theta. And in the bottom, I have sine theta cos theta, which actually is 2 sine theta cos theta. And that could be recognized as sine 2 theta. So if I'm really being tricky, what I've got here is negative cosine 2 theta in the numerator and sine 2 theta in the denominator. Ha, nice, short, and sweet. Let's now talk about vertical tangent lines. So vertical tangent lines occur when our slope is undefined. So we have a vertical tangent line when our slope is undefined. So let me just write down vertical tangent line, and let me just write down that the slope, or dy dx, is undefined. And when you have a ratio or a fraction, you would say that your slope is undefined when your denominator is 0. You can have any number in the numerator, but specifically it will be undefined when your denominator is 0. So to find when we have vertical tangent lines, we're simply going to take our denominator of dy dx, which is sine 2 theta, and we're going to set that equal to 0. That will tell us where we have a vertical tangent line. Well, sine 2 theta equals 0. Well, I like to look at it this way. I like to say, the sine of what is going to give me 0? Well, sine is 0 at every value of pi. So that means that our question mark can be equal to 0, our question mark could be equal to pi, our question mark could be equal to 2 pi, right? Every time we have a multiple of pi, sine is 0. Same thing in the negative direction, right? If we had negative pi, negative 2 pi, etc., etc., etc. But my question mark, so the sine of what is 0, and I said, well, those angles are simply 0, pi, 2 pi, negative pi. That simply was holding the place value for 2 theta. So that means that sine of 2 theta is going to be 0 when 2 theta, the angle, is equal to negative pi, when 2 theta is equal to 0, when 2 theta is equal to pi, and when 2 theta is equal to 2 pi. And I'll put dot, 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 because both in the positive and negative direction, I would continue listing values. Let's continue solving for theta. I can achieve that by simply dividing both sides of each of these equations by 2, right? And if I divide each equation by 2, that's going to give us the theta. So that means that the sine of 2 theta is 0 when theta is negative pi over 2, when theta is 0, when theta is positive pi over 2, and when theta is pi. Dot, dot, dot. And continuing in both directions. Our problem, though, asks us specifically to find the points at which the curve r equals 6 cos theta has a vertical or tangent line in this domain right here, in this restriction, where theta lies between negative pi over 6 and positive pi over 3. Now, the only value in my list that's in between negative pi over 6 and positive pi over 3 is this one right here. So it looks like there is a single answer. There is a vertical tangent line when theta is 0. Well, you'd think we'd be done, but we have one final step because the problem asks us to find the points x and y. Okay, so we have that r is 6 cos theta. X is r cosine theta, or in other words, x is just 6 times the cosine squared of theta. And y is r sine theta. Those are definitions, which is just 6 cos theta sine theta. Phew. Okay, so we have a vertical tangent line at theta equals 0. And when theta equals 0, r equals 6 cos theta, and correspondingly, x is 6 cos squared theta, y is 6 cos theta sine theta. And these come from the basic these two come from the basic identities for x and y. Those are our basic trig relationships, our polar coordinate. So when theta is 0, that means the x value is just going to be 6 times the cosine squared of 0. And the cosine of 0 is 1. And so that means our x value will be 6. And the y value is simply going to be 6 times the cosine of 0 times the sine of 0. I'm running out of space here. Whoops, sine of 0. The sine of 0 is just 0, and so that means y is 0. And so we would say that for the first part of our problem, we would have a vertical tangent line specifically at the point 6, 0. 6 for x, 0 for y. And this is where we have a vertical tangent. Now we could repeat the same process to find our horizontal tangent. But this time we have to set our numerator equal to 0. So now it's time to find our horizontal tangents, or the places or points on the curve where we have a horizontal tangent, and that's going to occur when dy dx is 0, or in other words, where the numerator of our fraction is 0. Doesn't matter what's on the bottom, but we care about the numerator being 0. So to find these points where this occurs, we simply have to take the numerator of dy dx, which is minus cosine 2 theta, and we want to set that equal to 0. Divide both sides by -1 gives us the cosine of 2 theta is 0, and follow that same argument like I did the other time. We're asking ourselves where or for what angles is the cosine 0 to start with. Well, cosine is 0 every odd pi over 2, right? So it would be negative pi over 2, positive pi over 2, 3 pi over 2, right? Every odd pi over 2 is where our cosine is 0. So that means specifically that 2 theta would have to equal negative pi over 2. 2 theta would have to equal positive pi over 2. 2 theta would have to equal 3 pi over 2. And if we divide both sides of our equation in each of the equations by 2, it looks to me like we're finding that cosine 2 theta is 0 when theta is negative pi over 4, theta is positive pi over 4, theta is 3 pi over 4. And remember our restriction, we can't forget that. It's negative pi over 6, less than or equal to theta, less than or equal to positive pi over 3. Of those three values, the only value that's between negative pi over 6 and positive pi over 3 is the middle value, theta equals pi over 4. And going back to our definitions, right? X equals r cos theta, but our r was 6 cosine theta. And so that means x is 6 cos theta. Y is equivalent to r sine theta by definition. And again, r is 6 cos theta, so y is 6 cos theta sine theta. Now, to find out what x and y are when theta is pi over 4, we simply have to plug in pi over 4. That means x is going to be the cosine of pi over 4 times the cosine of pi over 4. And the cosine of pi over 4 is root 2 over 2. So that means we're going to take 6 times square root 2 over 2 times square root 2 over 2. And that means x is just going to be 6 times 2 in the numerator divided by 4. And that's 12 divided by 4, or just 3. So our x value, where we have a horizontal tangent line, is going to be at x equals 3. And how about that y value? Remember, y is is r sine theta, but that's 6 cos theta sine theta when r is 6 cos theta. And let me erase. Instead of theta, we're actually trying to find the y value when theta is specifically pi over 4. So that's going to be the 6 times the cosine of pi over 4 times the sine of pi over 4. And, you know, what's interesting is that pi over 4, the sine and the cosine are identical, and so it looks like y might be the same thing. It's 6 square root 2 over 2 times square root 2 over 2, and we just calculated that out to be 3. So that means when x is 3 and y is 3, we have a horizontal tangent. And that's completed our problem. Just a couple extra steps in there. If you have any questions at all, please don't hesitate to reach out. I'll be happy to help.